So our goal in this video is to finish our XML deserialization. We have gotten to the point where our drawing is happy and it builds a draw transform, and the draw transform is happy. It creates the children, the type transform, and the two values. But the call here to build the children is actually using the apply method in the drawable, and we haven't done this yet. And the challenge here is the fact that a node that comes in as a drawable could be any of the various types. And so we need to make sure that basically what we're going to do is we're going to pull off from our node the type attribute. So all of our different nodes, whether they are the draw transform or the draw rectangle, have a type that lists the appropriate string. We want to take the text for that, and then I'm just going to use a match here. Now, once again, unfortunately, this is a piece of code that we're going to have to touch every time that we add a new drawable type. And I have to say, I'm a little, the design here, I have to match the strings exactly. So if I were to somehow, mistype this, I can do a copy and paste so that I can't mistype it. But I'd much prefer to actually have them in one place. Maybe I could have an array and drawable. We could think about how we'd want to do that, define constants in the companion objects, whatever. So if the type is a transform, then we want to return a draw transform, and we're going to use this apply method. So it is going to use the drawing and node. So really all that this apply method is doing is it's just passing on the responsibility to the various subtypes. It doesn't have any significant logic in it. It just looks at their type and then asks them to create themselves. So in addition to the transform, we have a rectangle, a text, and a maze. And this time I'm actually going to type stuff in, which of course means that I could mistype things, which makes me a little unhappy, but something that we could refactor later on if we decided that it was causing us problems. It's good to have things to refactor. Okay, so inside of our draw rectangle, we need to make a companion object, and it needs to have an apply method that takes a drawing and a node, and it is going to return a draw rectangle. And since I'm going to need to add this same type of code into draw text and draw maze, I will go ahead and start adding some of that. So our maze actually already has a companion object, so all I need is the apply method. So we'll start with our rectangle. Note at this point our drawable is happy because we've at least stubbed out all of that code. We just have to get it working. So what does our rectangle need? In addition to the drawing, it needs an X, Y, width, height, and a color. Okay, so let's do this. We're going to have at the bottom of this, it has to build the draw rectangle with X, Y, width, height, and color. And I need to spell draw rectangle correctly. And we don't currently have X, Y, width, height, or color. So val X equals, we take our node, we search for the X attribute in it, get the text, and convert it to a double. So X, Y, width, and height are all actually quite simple. Y, width, height. What about color? Color is not so simple. Okay, color winds up being serialized out using this format, so we'd need to search inside of there for the color. What I'd really like to do is I'd actually like to consolidate it. In fact, I'm probably doing this in two places. My text is also building a color, and it might be nice if I don't have that code duplicated, okay, if all colors are written out the same way. A reasonable place to put this would be a drawable, either inside of the drawable or the drawing companion object, one of those two. Since our drawing doesn't actually have any colors in it currently, I'm leaning towards the drawable. So color to XML is going to take a color of type color, and it's going to give us back an XML node. We import that. And so I want to take from this draw rectangle, I'm going to cut out the code that builds the color. And so now this should be happy. And instead, I am going to put inside of here drawing dot, except that, and it's drawable dot color to XML of my color. And it wasn't auto-completing, but it appears to be happy with that. I'm going to do the same thing in my draw text, and that way I'm not duplicating the code for generating colors. Similarly, I can put another method in here that is XML to color that takes a node, that is an XML node, and it gives us back a color object. And once again, the goal here is right now I'm doing this in at least two places. It's likely I'm going to add more. There will be more things with colors in the drawing program. So I don't want to have to duplicate this code in all those places. So how does this work? Well, it's going to build, I guess one way to do this, val red equals, we're going to take our node, we're going to search inside of it for the attribute red, text to double, because all of those, the red, green, and blue, are doubles there. Paste, paste, paste. Green, blue, opacity, green, blue, opacity. You can see why I don't want to duplicate this code. And then we're going to return a color made with red, green, blue, and opacity. So that generates a color for us, and now when we are deserializing here, I can make it so that color is equal to drawable dot XML to color of, now it's not node, it's node slash color, because it's a sub-element inside of the rectangle itself. And then I need to get off the head element of that, because remember, this slash gives us back a node sequence, and there should only be one color inside of a rectangle. Okay, so this goes through and deserializes a rectangle. What about our text? Well, we have the method here. Turns out that text needs the x, y, it needs the color, does not need a width and a height. Instead, it needs text. Well, text is actually fairly simple. The way we serialize this out, text is just inside of its own element, and we just want the text from it. So I'm going to take node, I'm going to, node, I'm going to search for text, no @ sign because it's not an attribute, and then pull the text out of that. And so we're going to make a draw text, XY text color with our D, and now our draw text is happy. At least it compiles. What about our draw maze? Our draw maze was remarkably simple in this regard. it's just going to say new draw maze because we haven't yet saved off any of our elements. And I believe the only argument we have to our draw maze right now is the drawing itself. Yes. Oh, and that's because this still says draw text, is why that's unhappy. Now that matches the type, and everything's happy. Okay, so we still have our saved drawing, and the format looks a little bit weird, but it had a transform that had a rectangle and some text in it, and we should be able to try loading this in. So we should be able to run our maze, and I think we've put in the code that would, let's double check that real quick. So the open, yeah, it should just build a drawing around that XML data. So if we do open and drawing 2, we get a new drawing, it has the color set, and it has text stuff. So we have now completed our XML deserialization and at least done minimal testing on it, and everything seems to work. So that completes our discussion of XML and looking at how we can use it to serialize and deserialize objects, in this case for saving it in files, but there are actually a lot of other things that you can do with XML to communicate things between programs in various ways.